And we are live. Okay, so today we're talking about graphing and translating parabolas. So on our warm-up, what we did on our warm-up is we actually looked at graphing these, right? And we put our numbers in, right? We did this, we plugged in 0, 1, 2, 3, 4, and it made these points. We've got the exact same graph. We plug in -3. -3 squared is a positive 9, right? -3 times -3. We plug in -2. -2 squared is a positive 4. We plug in -1. -1 squared is a positive 1. Plug in 0. 0 squared is 0. Plug in 1. 1 squared is 1. 2. 2 squared is 4. And 3. 3 squared is 9, right? How am I doing? And then we graphed it, right? We graphed it. We also looked at the graph on Desmos, right? So we also looked at the graph on Desmos. But I'm going to put the graph down again. So I'm going to have, these are points. -3, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are points. -3, 9, -2, 4. 1, 2, 3, 4. So point at -1, 1. So point at 0, 0. There's a point at 1, 1. There's a point at 2, 4. There's a point at 3, 9. Okay. And there it is. That's our parent function for our parabola. That's my parent function. Okay, so the parent function is like the basic. It is just the basic parabola. And then from there, we're going to move it. Okay? So, you ready? 0, 0, 1, 1, 2, 4, 3, 9. I'll say it again. 0, 0, 1, 1, 2, 4, 3, 9. I'll say it again. 0, 0, 1, 1, 2, 4, 3, 9. Got it? So that way, when I take and translate it, I'm going to do the same thing. All I got to do is figure out where to put the vertex. Okay, so I want to translate. So I'm going to translate my parent function. So we're going to do a translation. And the easy way to translate this is just to move the vertex. So my vertex is right there. And then if I translate my vertex, I'm going to move it to, in this case, it's going to be the opposite of the inside, right? We've learned that before, so we're going to translate. So it's always going to be the opposite of the inside. So I'm going to translate this to a positive 2, 1. So I'm going to take the vertex and move this whole entire graph over to up 1. That's what I'm going to do. So I'm going to take this graph and put it here. So I just translated it, positive 2 up 1, and then I'm going to put this graph right here. So you guys are all, when you're ready, I want everybody just to look up here, okay? Everybody look. Okay, just watch. 1, 1, 2, 4, 3, 9. Okay, watch. 1, 1, 2, 1, 2, 3, 4. Go over 3. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we know a parabola is symmetrical. So there's a thing called a line of symmetry, which goes right down the middle, right? You guys see that? So I like the line of symmetry. Oh, let me use a darker color than that. Let me just try to see. So I got a line of symmetry, which goes right down the middle. And it helps me graph the other points. That's a line of symmetry. And so once I get a line of symmetry, I just fold the points over. I got a point there. Fold the points over. I got a point there. Fold the points over. I got a point there. There you go. Boom. How's that? Now you could put this into your Desmos, into your calculator. You really could. But this is so fast the way I did. I mean, you can go, okay, well, back that up. I can go back that up. I can go parentheses, right? It's kind of a pain. I mean, I think the way I did is so much faster. X, subtract 2, squared, plus, hold on, give me a second, plus 1. There's my graph. Same graph, right? But I think it's so much faster just to do what I did. The 1, 1, 2, 4, 3, 9, right? Okay, so let's take a look at number 3. It's still our parabola because of the x squared. Okay, it's still a parabola. But we're going to move its vertex, so we're going to translate it to positive 3. Remember, it's the opposite. Positive 3. It's always the opposite inside. Always the opposite. So we're going to move it to a positive 3, negative 4. Okay? So the vertex, which is there, that's my parent function, is going to go to positive 3, negative 4. Okay, so we'll put that in there. So I'm going to put that graph in there. Positive 3, 1, 2, 3, 1, 2, 3, 4. Okay, got it? Now there's one more thing we're going to do, and that is this. This graph has a negative in front. What do you think that's going to do? It's got a negative in front. What do you guys think? Anybody have any ideas? What's the negative in front going to do? What's this negative right here? Emma, just say upside down, Mr. Davies. Yes, Emma, you're right. It's upside down. So it makes this graph, the negative, just upside down. So I'm going to make the graph go down, right? So I'm going to do this. I'm still going to do my, ready? Listen, 1, 1, 2, 4, 3, 9. Do you hear that? So I'm going to go 1, 1. So I'm going to go over 1, 1, but down because it's upside down. I'm going to go over 1, 2, down 1, 2, 3, 4, right? I'm going to go over 1, 2, 3, and then go 1, 2, 3, 4. It's going to be off my paper, but anyway, 9, right? I know that there's a line of symmetry which goes down the middle of it at the vertex. Here's my line of symmetry. So I also have the points that reflect over here, and then the other one's there. How's that so far? Okay. Now, I'm going to shift this up for a second and talk about domain and range. Okay. Domain. Domain's all my x values. Domain is my x values, or how wide is this graph? So the x values, how wide is this graph? Well, it's going up, and as it goes up, it's always going over. It's always going over, right? As this graph goes up, it's always going over. So the domain is everything. So we just say the domain is all real numbers. Which would also be the same as this one. As this one goes up forever, it's always going over, right? So the domain of this one, well, it's always going over, would also be all real numbers. Now I like this cursive R. It's just an easy way to write domain. Okay. Same thing's true of this graph. It's always going over, isn't it? Even though it's going down, it's always moving over, So the domain is all real numbers. So we know this on a parabola. The domain's always going to be Domain's always going to be the all real numbers because it's always moving over. It's always going over. Even though it's going down, 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 it's always moving over, right? So every x value is part of the graph. Now the range is different. Let's talk about the range. So the range is the y values. It goes up. But there's nothing down here. The graph. There's no graph down here. So this range starts at 0 and goes up. So we'd say the range is y is greater than or equal to 0. It starts at height of 0 and goes up. Okay, the range here on this graph starts at a height of 1, right? A height of 1 and goes up. It doesn't go down here. There's no graph down here. So I'm going to say the range is y is greater than or equal to 1. Okay? The range on this graph, it goes down, right? It goes down. The y values goes down. So it goes down from -3. So we're going to say y is less than or equal to -3 because it goes down. Okay, show me thumbs up. Does that make sense? Okay? Does that make sense, everybody? Okay, good. Let's flip the page. Okay. So example 4 says describe. So what's going on? So we had an x squared, and then we did some things to it. So first of all, I see that we moved it. So we did a horizontal. Shift to the left. Horizontal shift by 3 to the left. To the left? But that says +3. And I'm telling you went to the left because it's the opposite, remember? And I did a vertical shift down 6, because that's my -6, right? And I did one more thing. I did a shrink, a vertical shrink of 1/2. Okay? So I want to show that to you, okay? I'm just gonna use my calculator. Okay, let's go y equals clear. You don't want to clear. Okay, now I want to show you more than anything. I want to show you this. Okay, 0.5 parentheses x plus 3 squared minus 6. Okay, now I really want you to see this. Okay, see the +3? Okay, see the +3? My calculator's not going to lie to me. There's no way. So I graph it. +3, right? It went back 3, didn't it? You see that? It went back 3. It didn't go over 3. It went back 3. Now here's why, and I would like you to know why. What x value right here would make this 0? What x value would make this 0? -3, isn't that right? Do you see that? -3 plus 3 make it 0. The vertex is at the lowest point, right? So what x value would 0 it out? It's always got to be the opposite, okay? All right, last but not least, example 5. So here's f of x. So I know this graph, and I'm just going to do a real rough sketch of it, okay? It doesn't have to be perfect, okay? Okay. So this is the graph I have. This is f of x, and I'll put f of x in a different color. Let's see what I got. Let's put it in blue, okay? I'm going to put this one in blue, okay? -1, -4, okay? There's f of x, okay? I went opposite, right? And then down 4. Okay, that's my parabola. Now, I want to move this graph. So I want to move this graph how? Well, I'm going to move this graph. Let's see what kind of a good color here. I got to sharpen all my pencils. Okay, so I'm going to move it. This one, I'm going to move it 5 to the right. So I move this graph 5 to the right. So I'm going to go 1, 2, 3, 4, 5. And then 4 units down, okay? So 1, 2, 3, 4, 5, 1, 2, 3, 4. So the parabola, the new parabola is going to go to here, okay? It went to the right 4, so I moved it to the right 4. And then I went down by 4, okay? So what's the new equation? Well, I'm just going to do the math. So I'm going to say g of x is equal to, because g of x is my new, I got to have a new name because it's a new graph, right? So I got a new name called g of x. It's going to be x plus 1 and then minus 5. minus 5, because I went to the right, so it's the opposite, right? Squared minus 4, but then I'm going to also go down another minus 4. Whoops, I wanted to do that in a different color. So here is that, and here is that, okay? So then I'm going to simplify this, and my new answer, my new graph, my new equation is going to be g of x is equal to x minus 4 squared, right? Because I just went 1 minus 5 minus 8. And there it is. That's the new equation. So I didn't take the parent function. This time I just took this function and I moved it to the right 5, and then I moved it down 4. Okay? That one's a little bit harder. Thumbs up, see what I did? Okay. All right. Let me stop my recording, and then we'll take a look at the homework, okay?